Welcome back, geometry students. We're going to be finishing up with example 2, kicking it into overtime here. So this is a very advanced problem, but one that really challenges your thinking and understanding of segments, the area of triangles, circles, etc. So let's go ahead and get started. So this example is if the area of a segment is 114 meters squared and the angle measure of the sector is 90, then what is the radius? The first thing we should probably do is set this problem up. We need a game plan. As with any kind of big problem, we need a game plan, and then essentially once we break it down into components, it's easy to plug in and then go from there. So the area of a segment. So we already understand the area of a segment to be the area of a sector minus, and let's use orange here, minus the area of a triangle. So we know the area of a sector to be pi r squared times your theta, your central angle or arc measure, divided by 360. And we know the area of a triangle. Well, we have two options here. The main one you're going to be using for circles is 1/2 b times c times sine of a, which really becomes 1/2 b squared sine of a with circles because b is the radius. But this is important because you can use this with any central angle that's given. But in this case, we're given that there's a 90-degree angle there, so we can use 1/2 base times the height of the triangle because we know that the base and the height are perpendicular given this 90-degree angle. Now, because the base and the height are both measures of r, we're going to have to change this formula in a little bit, but I just wanted to give a sneak peek on what we're going to be doing there. Okay, so we're going to write 1/2 base times height. Now, one of the things, let me write area of the segment. Now, let's go ahead and try to decide some of the things we know and some of the things that we're trying to find. So one of the things that we're trying to find, one of the things that we know is that the area of the segment is 114. So we're going to go ahead and plug 114. We don't need to include the meter squared just yet. Now, the thing that we're trying to find is the radius. So I'm going to make this my green letter. That way you can kind of see the difference. So we have pi, my radius squared. This is the thing I'm trying to find. Now, I know my central angle, it's 90. So I can put times 90 over 360 minus 1/2 base times height. Now, what is my base? What is my height? We know the base and the height need to be perpendicular to each other, so it doesn't really matter which one we call the base or the height. In this case, they're both r. So I alluded to this earlier. We could write this as 1/2 r times r or 1/2 r squared. This is the key to this problem. So 1/2, and we're using green for r squared. You know what? I don't know why I chose green. Why don't I change it to red since it's already red in the problem? So I'm going to change this to red. Sorry for giving you the expectation or the hope that it's going to be green, but sorry, I'm changing it back to red. Okay. Now we're ready to simplify. I'm going to use, how about this? I'll compromise. We'll use green for when we simplify from here. So now we're simplifying, so we're just kind of combining things together. So we have pi r squared, I'm going to kind of put towards the end. I know 90 divided by 360 is 1 over 4, so 1 over 4 times, and now we have my r squared. Okay, minus, and we still have this, minus 1/2 r squared. We have a couple options from here. We could either convert these into decimals and then solve from there. So I'm going to go ahead and do that first because I'm guessing that will make the most sense for most of my students. So just so you understand the problem, I'm going to be multiplying everything in front in its decimal form. So I'm going to multiply this in its decimal form, this in its decimal form, keeping the r squared intact. So I do pi divided by 4, or times 1/4, you get the same thing. So I get 0.785, and I'm just going to write the first three digits, r squared. And then we have 0.5 r squared equals 114. So now I do 0.785 minus 0.5. Oops, sorry, I messed up on my calculator. Minus 0.5, and I get 0.285 rounded r squared equals 114. What do I do next? Well, I need to get the r by itself, so I divide both sides by 285. Now, on my calculator, I'm not just doing 285. I have it stored. So I'm going to go ahead and select that and find out the exact. And rounded, I get about 400. I'm going to round it to 400. Okay, and I did do some rounding there to get the numbers a little bit good. You should get something like 399.44. And I'm going to round up just to make this a nice even number, okay? That's the reason why I'm doing that, just so you know, okay? So now how do we get the r by itself? We have to take the square root of both sides. To undo the square, we square root it, and we get 20 equals r. Technically, it's plus or minus 20, but we're not going to use negative numbers for distances, so r equals 20. And that's how we can do this problem. Now, let's say that you don't have a calculator and need to solve this. Let me show you the other way in which you can do that. This way involves factoring. So I'm going to go over here. Now, if you're good with this, just stick with this, but I'm just going to show you an alternative. So if this confuses you, don't worry about it. But I do want to show students that are willing and able for the challenge to see this problem. So what I'm going to do is I'm going to factor out an r squared in the same way that if we have, for example, 3x minus 5x equals, 10, we could factor out an x in both those terms. And the reason why I'm factoring out is because I have pi, and if I want to leave it in terms of pi, I need to factor out. So I could technically factor out an x, and then I have x, and then 3 minus 5 here equals 10. This would be especially useful if I had something like this. Let me erase this real quick. If I had 3 pi times x minus, 2x. I could factor out an x, and I'd be left with 3 pi. Whoa, hold on. 3 pi minus 2 equals 10. Then from there, it'd be a little bit easier to solve. So what I'm going to do here is I factor out the r squared and what's left inside. I have pi over 4 minus 1/2. Now what I can do here is I want to combine inside the parentheses, and I want all underneath one denominator. So I'm going to change this 1/2 to 2 over 4. That way I have a common denominator. So now I have 114 equals r squared times, this is where I'm going to combine the denominator. I have pi over 4, so pi, we have a common denominator 4 minus 2. So pi minus 2 over 4. Now, since this is times r squared, and I want to get the r squared by itself, I'm going to multiply both sides by the reciprocal. Pi minus 2 under 4. So I'm going to go ahead and do that. Pi minus 2. So I get r squared equals 114 times 4 over pi minus 2. And I get 114 times 4, which is 456, over pi minus 2 equals r squared. And finally, I take the square root. And I get square root of 456 over pi minus 2 equals r. So we don't have a pretty looking answer there. You could, if you wanted to, you could do this first and then simplify it on the calculator. Obviously, using the calculator is a lot more useful here. And what we could do is we could simplify this radical, and then we could simplify this. But I just wanted to show you that you could do some manipulation to get an answer that you don't need to use a calculator for. So obviously, the calculator helps. Hope this clears some things up in terms of the process of solving for the radius once you're given the area of the segment. And I look forward to seeing you next time. Take care and be good, be kind, be true, be nice, and be honest.